We need to obtain the value of derivative of y with respect to x at x equals to a whenever y is given by this particular expression. So let's begin. So we will start with whatever we are provided with. So here we are given with the value of y, which is a raised to the power of x plus e raised to the power of x plus x raised to the power of x plus x raised to the power of a. Now what we'll do, we'll take the derivative on both sides with respect to x, which will be equals to, we'll take the derivative of the individual terms on the right hand side, so with derivative with respect to x of a raised to the power of x plus derivative with respect to x of e raised to the power of x plus derivative with respect to x of, so here we have x raised to the power of x, but we'll not write it as x raised to the power of x. Instead, we will make use of the fact that whenever we have e raised to the power of natural log of a, so this is always equals to the value a. So that means if we consider the value of a to be equals to x raised to the power of x, then using this particular form, we can rewrite x raised to the power of x as e raised to the power of log of x raised to the power of x. Now we also know that there's a property of logarithm that states that whenever we have log of a raised to the power of b, so this value is also equivalent to b times log of a. So that means we can ultimately write x raised to the power of x as e raised to the power of x log of x. So what we have done is we have brought this particular x to the front and multiplied with log of x. So that means here we will use e raised to the power of x log x instead of x raised to the power of x. It will be the same thing, plus derivative with respect to x of x raised to the power of a. Now let's find out the individual derivative. Now derivative of a raised to the power of x, since this is an exponential function, we have a raised to the power of x, but here we have an a here, so we'll have to multiply it with natural log of a, plus derivative of our exponential function, this is the function itself, e raised to the power of x, plus derivative of e raised to the power of x log x, so this will be e raised to the power of x log x. But since we have an x log x instead of x, we'll have to use the chain rule, so we'll multiply it to derivative with respect to x of x times log x. Now for the fourth derivative, all we have to do is use the power rule, so this will become a multiplied to x raised to the power of a minus 1. Fine. So this gives us x e raised to the power of x times log of a plus e raised to the power of x plus e raised to the power of x log x, which is actually x raised to the power of x. So let's bring it back to its original form, x raised to the power of x times. So here we'll have to use the product rule. So when we use the product rule, our value will be 1 plus log of x plus a times x raised to the power of a minus 1. Now we have obtained the value of derivative of y with respect to x, but our goal is to find its value at that particular value of x, which is at x equals to a. So our derivative of y with respect to x at this particular value of x equals to a, so this is given by a raised to the power of a times log of a plus e raised to the power of x will become e raised to the power of a plus a raised to the power of a multiplied to 1 plus log of a plus a multiplied to a raised to the power of a minus 1. Right. So let's further simplify. So we have a raised to the power of a times log of a plus e raised to the power of a plus, so we will multiply a raised to the power of a with 1 plus log a. So we have a raised to the power of a plus a raised to the power of a times log a plus, so here we have a raised to the power of 1. So when we combine the power, so this will be simply become a raised to the power of a, by using the laws of exponents. Now what we can do, we can combine the first term and the fourth term to get 2 times a raised to the power of a times log of a. We can combine the third term and the fifth term to get 2a raised to the power of a, and we are left with the second term, which is e raised to the power of a. So this is the required value of our given derivative at this given value of x equals to a.